Okay, dear students, in the last class we have completed concepts and exercise 2.1. Okay, exercise also we have done in relations and functions. Actually, original relations we have not yet entered, but we have seen ordered pair, Cartesian product, such that we have seen, and we have done exercise also. Okay, now before 2.2 exercise, uh, concepts we will see. These concepts are relations. What are relations and all we will see. Relation, there is no specific definition in the book. Okay, relation is between, like that he has told, but there is no specific definition in the relation. Okay, let us see how we can understand about the relation. Let us understand the relation. Okay, relation will be between Cartesian products of ordered pairs only. That is why slowly we are coming. See, in first chapter we have learnt about sets. In second chapter, first, rather than relations, we have learnt about Cartesian product, ordered pairs. Okay. Now relation also between Cartesian products only. Elements of Cartesian products only. Okay. If you have understand Cartesian products or ordered pairs, the relation also comes among them only, but there is no such specific definition for relation. But relation we can define ourselves. See, x is equal y is equal to x plus 1. That is also one definition for relation. Okay, see, how can we understand about a relation? Okay, say a is equal to 1 2 is there, yes. P is equal to 3 4 is there. Okay, now these two are sets. Okay, these two are sets. Say ordered pair or Cartesian product B is equal to what we are going to write? We are going to write 1 comma 3 comma 1 comma 4 comma 2 comma 3 comma 2 comma 4. Okay, this is Cartesian product of sets A cross B. Okay, and these are ordered pairs. See, all elements belongs to A, comes in x coordinate only. You see, these are A, 1 and 2. 1 and 2 comes under x coordinate. 3 and 4 belongs to B. Those elements are coming under y. 3 4 3 4 y coordinate. Okay, x coordinate, y coordinate, x coordinate, y coordinate. Okay, this is called ordered pair. Now what we can understand about relations? Relations also a subset of the Cartesian product. That means if you are making a Cartesian product between two sets, each set may be having some elements like here 1 and 2, here 3 and 4. Why after making Cartesian product, some elements will come. Okay. Now, if you see subsets, so subset will be much bigger. 5 will come, full set will come. See, subset I am writing not for 4 elements, for 2 elements I will write subset. Actually I know, even though again I am writing for understanding this concept also. You see, if A is equal to, rather than A I write P. P is equal to say 1. Q is equal to say 4. Okay, how we do Cartesian product? P cross Q is equal to 1 comma 4. That's all. 2 elements will come because there is no chance to make something. But see, this is Cartesian product. But what about subsets? Subsets 2 power 2, that is equal to 4 subsets will come. 5 will come, full set will come. Okay, then single element will come, then single element will come. Close. These are subsets. You understand now? Now relation is what he is mentioning. Relation also subsets of this Cartesian product subsets. You understand now? Why? Because see, subsets are bigger. See, Cartesian product is okay. 1 4 means 1 4 has come. Okay, there is no chance. But here you see how many have come? 4 have come. If you compare this subset with this subset, here how many are going to come? 1 2 3 4. 2 power 4. That means 16 subsets are going to come. Relation will be the subset of these subsets. Okay, or subsets or full set. That is the concept we have to understand. Okay, now we see what is the relation between these two and all, and how we can understand how many relations will come. These are also we have to understand. Okay, here you see simply P is a set separately, Q is a set separately. I am writing here those sets. Say P is equal to 1 2 3. Q is equal to 1 4 9. These two sets are having relation. Okay, relation on Q, or we can say our relation from P to Q also we can say. Why? Because that is very essential. Relation on Q. Relation on Q or relation from P to Q or to Q. Like that we have to spell like that. Okay, relation. And a relation also shown the symbol of R. This is not real number. This is relation only. We should not get confused. Relation is represented by the symbol R. See, we can say notation, not representation. Relation notation is R. Representation like sets. Sets, how many types are there? Representation, roster form is there, set builder form is there, Venn diagram is there. Here also roster form is there, set builder form is there for relation representation. And the third one, there Venn diagram will come. Sets, here arrow diagram will come. Arrow diagram. Arrow diagram. How arrow diagram? See, arrows are there. Arrows from where to where is there? From P to Q, from A to B, from A to A. Okay. Like always, subset will be left side. Like always, the relation from will be from left side. To will be right side. Left to right, arrow will be there. This is representation, arrow diagram. Set builder form, roster form and all, like sets only we can make the representation of these this thing. Define, how to define? See, definition is different definitions will be there. Each situation depends on situation. Here I can say, you see, Q is the square of P. This is the relation. Relation R is equal to Q is the square of P. If you see here Q, 1 square, 2 square, 3 square. Okay. See, these relations may change according to situation. Whatever you want, whatever examiner gives, like that. Okay, but these relations come under subsets only. If you make subsets of these subsets, Cartesian product subsets, only relation will come. Okay, that is the concept we have to understand. Okay, first we see 3 types of this thing, relations. Then we go for more terminology. What are all their contents inside the relation and all. Okay, now I am writing set builder. Sorry, roster form. Roster form R is equal to 1, 1, 2, 4, 3, 9. Okay, this is not an ordinary product. Ordinary product means 1, 1, 1, 1, 4, 1, 9 will come. 2, 1, 2, 4, 2, 3, 4, 2, 9. 3 1 3 4 3 9 will come. That is Cartesian product, but this is not a Cartesian product. This is a relation, but a relation is a subset of Cartesian product. See, if we make Cartesian product, 1 1 1 4 1 9 will be there, 2 1 2 4 2 9 will be there, 3 1 3 4 3 9 will be there. But among those sets, elements, these are subsets if you observe. Okay, that is why relation is a subset of Cartesian product subsets. Okay. Now this is the roster form. You know very well roster form. Simply we can write, and we will write a set builder form also. Second form set builder form. Set builder form R is equal to, okay, actually relation on R, relation on Q we have to write, but that we will see afterwards. Now we understand first in set builder form how we are writing x comma y in parenthesis colon. In set builder form, in sets for all values of x, only x colon will come. These parentheses also will not come, small brackets also will not come. But here under parenthesis x comma y colon it has to come. For all values of x there, for all values of x comma y we can write here. Okay, that means whatever we are writing here, those will be applicable to x, y both. Conditions also we will make. Y is the square of x comma or colon semicolon. Okay, y is the square of x belongs to, y is the square of x, sorry, p belongs to x comma q belongs to y. Okay, p belongs to x side, q belongs to y coordinate, and x is greater than or equal to 1, less than or equal to 3. Even you can write x is a natural number. X is a natural number. Okay. See, this is the set builder form of representation. Roster form simply you can write by seeing combinations and all. That even sets also we have seen sets. In sets there will be no combinations, and normally we will write 1 or 2 or 3 or 4 like in roster form. But see, sometimes 1 2 3 4 will come for set builder form, roster form of representation. Pairs, ordered pairs only will come. Why? Because we are in relations and functions. Here ordered pairs will come. Set builder form once again we see. Relation R is equal to, for all values of x comma y is the square of x. Y is the square of x. 1 square, 2 square, 3 square. Okay. X is a natural number. X is a natural. Why? Because like this we have written means whatever may be the number we can take, but that we should not take. You should take natural numbers only. Natural number starts from 1, you know. P belongs to x, Q belongs to y. That also we have specified. And x is greater than or equal to 1 and less than or equal to 3. That means 1, 2, 3 only we have to take by x. Then y also accordingly it will come. This is the representation of set builder form. Third form is when arrow diagram. Arrow diagram is this only. For making arrow diagram, you must have to make roster form. By seeing roster form only you can make arrow diagram. Directly you cannot make by seeing set builder form. First you make, even if they give set builder form, you convert into roster form. By seeing roster form you make arrow diagram. This is the arrow diagram. I have told 2 circles will come. Circles are ellipse. X elements will come in P or A. Y elements will come in Q or B. Here A or B, P or Q or A or A, whatever it may be, according to question. From relation from x to y, relation from s to t means s will come, t will come that side. Like that we have to draw the arrow diagram. Arrows are from left side to right side. That means p to q, a to b, s to t, x to y. Like that we have to see. These are all comes under x coordinate. These are all comes under y coordinate. That means p belongs to x, q belongs to y. That also is there. Arrows direction towards right side. Second, this one. And each element should accordingly see. Here 1 to 1 means 1 to 1. 2 to 4 means 2 to 4. Like that we can make the arrow diagram. This is the arrow diagram. If you understand up to this, then we go for some terminology inside. Domain is there, range is there, number of elements, how they come and all are there. Okay, those elements are, those definition also or concepts also we will learn, and we go for exercise. Why? Because not much concept is there inside before going to 2.2 exercise. Okay, just I am rubbing this side. Let it be this only. Now we see some terms. What are the terms inside relations and all? Okay, 4 or 5 terms all comes. Domain will come. Domain of R, relation R. And okay, let us understand each one by one. Domain of R means when relation is there. Relation is there means, relation means, see, single set cannot make any relation. One set to another set, or this set to this set itself should have a relation. A to A, P to P, or P to Q, or A to B will have relation. Relation between two sets normally. That means same set you have to write that side also, and you have to make relation. For making relation, two sets are required. This is very important. Okay. Domain of R means you have to take left side elements which are having relation. You may say, sir, here all are having relation, we can take all, but sometimes here 4 also may be there. Okay, but you should not take 4 in domain. Domain here what will come here, 4 is there inside, but no relation is there outside. Domain of R is equal to 1, 2, 3. This is domain. Domain means set of elements in a relation from A. If the relation between A and B, the set of elements in A which are having relation is called domain. You understand properly? Relation is from P to Q, but the elements in P and having relation. 4 is not having relation. You see, 4 is not having relation to Q. 4 is simply lying in the P as a set, element in the set. 4 doesn't come in domain. That you have to understand. 1, 2, 3 are having relation. That is why 1, 2, 3 elements comes under domain of R. Domain of R we have to write. Even if you write domain also, that is not wrong. You can write also. Okay. See. Now second term is range. Range of R. Now how we have taken domain, like that range also we can take, which belongs to Q. That means here what is Q? Say I will write here 5. Again one element is there 5. You understand now? But you should not take all 1, 4, 5, 9. You have to take 1, 4, 5, 1, 4, 9 only. That means you should not take 5. 1, 4, 9 only. 1, 4, 9. 1, 4, 9 is range. Same like definition. The range of relation is elements in B which are having relation with A. See, 1 is having relation with A, 4 is having relation with A, P. 9 is having relation with P. Okay, maybe with different elements. Sometimes with two elements also may have relation, that is different case. Okay, we will see. While entering a exercise, automatically such type of problems are going to come. But initially, concept we have to understand. 5 doesn't have any relation with P. That is why 5 doesn't come under range. Domain and ranges are very important for you. For class 11, class 12, in all chapters, almost these two are going to come. Okay. Approximately you can take domain and ranges for the remaining chapters, input and output like. That means domain means input, range means output. If you give some input, how much output will come in trigonometry or whatever it may be. Like that also you may have to take. But here you understand relation like. But here relation also, in between we have given x square. If you put x square here, one enter x square, then after entering x square it is becoming square and output is going to come 1, 2, 4, 3, 9. That means input, output. But now I am not telling this input, output and all. In different chapter or different concept, even relations also different functions and all, I am going to tell that. Input, output. Input, output like domain and range you have to apply for entire class 11 and class 12 chapters. Okay? Okay. Now you see. Range also you understand. Why? Because simply I have written range also. Now we go for codomain. Codomain. Same codomain of R is equal to. Now you can write all elements 1, 4, 5, 9. Codomain means there is no restriction of having relation or not. Whatever the elements are having in Q, all you can write. In Q, all elements you can make one set and that is going to be called as codomain. This is codomain. Okay. Now we understand domain, range, codomain. And two more words are there, image and pre-image. Those also we will see. Okay. Image. First we will understand image. Then we understand the pre-image. Image means here in Q area, range area, we can say range. Image is a range. Image is a element in range which is having relation with A to same. That means here 4 is image of 2. 9 is image of, see this 9 I will write like this. Why? Because you may get confusion. 3 is having relation to 9 only, 5 is down. Okay, 5 doesn't have any relation. Now you see, 9 is the image of 3, 1 is the image of 1, 4 is the image of 2. Okay, now I write here, 4 is the image of 2. 9 is the image of 3. Okay, image means like a mirror image. Original, mirror. Original is left side, mirror is right side. If you keep here 3, 9 is the image. Okay, you understand now? That means image is not a set, image is an element. Domain is a set, range is a set, codomain is a set. Set. Image is not a set. Image is an individual element. 1 is image for 1. 4 is image for 2. 9 is image for 3. 9 is not an image for 1 or 2. Okay? 9 is only image of 3. This you have to understand. This is a concept of image. Then we go pre-image is there, afterwards number of sets, number of relations also is there. These two we complete and we go for exercise. Okay, now pre-image. Final, pre-final. examinations will be there for us. Like that, image, pre-image. If this is image 9, pre-image is 3, that's all. Two is the pre-image of 4. Okay, I have written only one, remaining all I will explain. See, when 4 is the image of 2, automatically 2 is the pre-image of 4. 2 is the pre-image of 4. Like here also, this is also image and pre-images are not sets. Image and pre-images are individual elements. Okay, but range, codomain, domain are sets. Okay. When 2 is pre-image for 4, then 3 is pre-image for 9, 1 is pre-image for 1. Okay. 4 and 5 are neither image nor pre-image. You understand now? Why? Because when a relation comes, then only image and pre-image concept will come. When a relation comes, then only domain and range will come. Codomain without a relation also all the sets will come. All the elements in the set will come. Image and pre-image don't come without a relation. Here 5 and 4 don't have any image or pre-image. Okay? This you have to understand. Now last one concept is there, number of relations. How many relations will be there? That formula written, but we don't see. We written that we understand. Say in A, P elements are there, in B, Q elements are there. Okay. Total elements in Cartesian product is going to become PQ. Total subsets are going to become 2 power PQ. This we have already known. Okay. Like that, total relations also 2 power PQ. That means if A is having 2 elements, B is having 2 elements, 2 into 2, 4, 2 power 4, 16 relations will come for between A cross B. A cross B, 2 by 2 is equal to 4, 2 power 4, that is equal to 16 relations will come. If this is 1 and 2, 2, 2 power 2, 4 relations will come. Correct, na? 2 into 1, 2. 2 power 2, 4. 4 relations will come. 3 into 2, 6. 2 power 6, 64 relations will come. Okay. See, power subsets of all power set, product of Cartesian all, we can make those as relations. Okay, number of relations. Okay. This is total relations are number of relations. Number of relations is equal to 2 power PQ. P is n of A. Q is n of B. Okay. This is all related to Cartesian part. One by one we are coming. If you understand all these up till now, yes, concepts over. Okay, we need not tell anything. We can go to exercise 2.2. All I have explained. Number of relations also I have explained. I need not write what are the relations. In the last example, last class example, 8th problem I have made all the subsets. Total 16 subsets. Those are our relation only. Okay, like that you have to understand. Why? Because same concept is there. You see 2 power PQ. Number of relations. Okay. Shall we go exercise 2.2? Okay. Okay. See exercise 2.2. First problem. What they have written. First question. Let a set having elements 1, 2, 3, 4 up to 14 natural numbers starting from 1 and ending 14. Okay. Define a relation R from A to A. Here R is a relation, not a real number. R from A to A. That means set also A, the left side also A, right side also A. Relation from A to A we have to write. the relation is giving. How relation R is equal to, for all values of x comma y, 3x minus y is equal to 0. That is the relation here. Okay, 3x minus y is equal to 0 is the relation where x, y both belongs to a. Why? Because x also y also y. Yes, sorry, x also a, y also a. When relation is from a to a means like that only. Okay. Write down its domain, codomain and range. Okay. All it has given. Okay. To understand one diagram also I will write here for easy understanding. Okay. Say here 1, 2, 3, 4 like that up to 14 are there. A. Here also 1, 2, 3, 4 like that up to 14 are there. Why? Because both are A, he is clearly mentioned. This is also A, this is also A. And the relation will be there in between A and arrow diagram will go from A to A. Okay, arrow diagram we will wait, we will see what are all solutions are going to come. According to solution we have to write arrow diagram. But like this is going to come. What you have to understand here, some conditions are there. See, A is 1 to 14 means here 1 to 14 only you have to take. First point. 1 to 14 only you have to take. You should not take more than 14. And the relation condition has given 3x minus y is equal to 0. Whatever the result will come here, that relation you have to make. That means x from starting 1 you have to take. Y, what result is going to come, that element you have to make relation. Okay, let me write here 3x minus 5 is equal to 0 comma y is equal to 3x. Shall I write like this? Why? Because y goes automatically 3x is equal to y it becomes. Okay. Now first I take 1. Why? Because 1 is there. X is equal to 1. Sorry. X is equal to 1. Then y is equal to how much it is going to come? 3 into 1, that is equal to 3. That means here 1 comma 3 set will come. You understand na concept? Okay. Second time I take 2. Y is equal to 3 into 2, that is equal to 6. That means 2 comma 6 set is going to come. You see here. Y is equal to 3x is there. X 1 by 1 we are taking. What we have to take? X 1 to 14 are there. 1 to 14 are there. X 1 to 14 we may take, but wait. How I am taking, you see. 1 you have taken, 1 3 has come, 3 has come, 1 3 is set. Set means relation. Okay. Or else once for all I am going to write here also. Okay, wait. Okay, 1 3 has come. 1 3 has come and relation also I am making. Okay, step by step we will do. Why? Because this is the first concept for you. In 10th it is not there. That is why I am showing a little bit patiently. X is equal to 3 comma y is equal to, why? Because we have to take 3 also, na? 3 into 3, 9. That means 3 comma 9. Okay, this also we have to write, na? We have forgotten. 2 to 6, 3 to 9. These relations also we will make. Okay. Okay, shall we go for 4? X is equal to 4. Y is equal to 3 into 4. That is equal to 12. Comma 4, 12. Okay, 4, 12. 4, 12 also you write. 4, 12. Make relation. From 4 to 12 also relation is there. Okay, now let us go for 5. X is equal to 5. Y is equal to 3 into 5. That is equal to 15. Then you wait. Why? Because is 15 is there? Not there. Then we have to stop there. This will not come. Why? Because 15 is not available with us. Relation is from A to A. A is having up to 14 only. Starting from 1 up to 14. Starting from 1 up to 14. If 14 is there, okay. More than 14, then you should not take. Okay. This is the relation of arrow diagram. Now you see, logic is here. Relation is from A to A. Relations we are showing, but unshown elements are there. Here 5 is there, 6 is there, like that up to 14 are there. Here also 1 is there, okay, 2 is there, like that up to 14 are there here also. Okay, these dots are numbers, remaining numbers. In A also 1 to 14 are there. In this side A also 14 are there. 1 to 14 elements are there. But relation is not there. Relation is between 1 and 3. Relation is between 2 and 6. Relation is between 3 and 9. Relation is between 4 and 12 only. These 4 relations only are there. Remaining relations are not there, but elements are existing in both sets. That concept you have to understand. Okay. Now, roster form I am writing. Why? Because he asked us to write a defined relation, and set builder form he has given. Write its domain and then. Okay. Say roster form relation R is equal to 1, 3, 2, 6, 3, 9, 4, 12, close. This is a relation. Even this working and all you need not do, but for your understanding I have done. Draw diagrams also. If they ask you, you have to draw, or else you need not draw also. But this roster form anyway you have to write. Why? Because set builder he has given means roster form you have to write. If they give roster form and ask you to write in set builder form, then set builder form you have to write. This is the relation. Okay. Now we write domain, codomain and range. That was also you asked, na? Domain of R. Okay. Domain is not a ordered pair. Domain is elements only, like set. Okay. Domain, what are all there? I said even though 1 to 14 elements are there, but relations are having only 1, 2, 3, 4. Only 1, 2, 3, 4 only the domain. You understand, na? Okay. Now I am writing range. First we write range. Then we go for codomain. Range of R you can write. I have written only range, but you write range of R. Okay. Range. Range is which elements are having relation only, range will come. 3, 6, 9, 12 only. These only range. Domain, range. Domain is 1, 2, 3, 4. Range is 3, 6, 9, 12. This is the answer for your these two. Domain and range. Now codomain also we have to write. Codomain is equal to. Codomain means what are all the elements existing in this side, all will come. Whether it may have relation or not. Then entire this A will come. 1, 2, 3, like that you can write up to 14. Okay? Or else you write all 14 numbers, that is not wrong. Why? Because 14 is limited only. If infinity is there, you need not write, but up to 14 means even you can write also. That is not wrong. See, if you observe, domain means whatever the relation having those elements left side. Well, here both are A, that is why A or B I cannot say. Left side, always left side domain. Range is always right side, but relation. Those elements should have relation. Codomain means right side in B or right side or in Q, all elements will come. Okay. Here image, pre-image they have not asked, but I am telling you 12 is the image for 4. 6 is the image for 2. 1 is the pre-image for 3. 3 is the pre-image for 9. Okay, this you have to understand. We have finished this first problem. Let us go for second question. Okay. See the second question. Define a relation R on the set n of natural numbers by R for all values of x, y. Y is equal to x plus 5. X is a natural number less than 4. X, y belongs to n. Both belongs to natural numbers. Depict the relation in roster form. Write down domain and range. Okay. Okay. Let us see what input he has given. Input he has given x is a natural number less than 4. That you have to mention here. You see x is equal to 1, comma 2, comma 3 because x is less than 4 and x belongs to n. Okay, x, y both belongs to n only, but for x sake I am writing here. X belongs to n, x is less than 4, then x is equal to 1, 2, 3. This we have written. Y has to be derived. Y directly you cannot write. Y formula is there. Y is equal to x plus 5 they have given. When x is equal to 1, y is equal to 1 plus 5, that is equal to 6. When x is equal to 2, y is equal to 2 plus 5, that is equal to 7. When x is equal to 3, y is equal to 3 plus 5, that is equal to 8. See here, if you observe clearly, for x only he has given control. X should be less than 4, but y they have not given any control. That is why y is going more than 4. Okay. See, if we observe here, 1, 6, 2, 7, 3, 8. See, x coordinate 1, 2, 3 only, but y coordinate 6, 7, 8. 6, 7, 8 are coming no more than 4, but what is this 4? This 4 is controlling by x only. For y there is no control. But x, based on x, y value is coming. Okay. But y, up to where you can go, y is also n, natural number only, but there is no control. For x they have given x should be less than 4, that means they are controlling x. These are the set. Okay. Now roster form you can write like this. Relation R is equal to, why? Because here a, b not mentioned, that is why simply you can write relation R is equal to 1, 6, 2, 7, 3, 8, then close. This is the roster form of relation. Up to here you have depicted the relation in roster form. This over. Okay. Now write domain and range. Those also we will write. Domain of R. You write domain of R. Why? Because it depends on examiner. If you write only domain, some examiners may not accept. Domain of R. Domain of R means 1, 2, 3. Okay. 1, 2, 3. Range of R is equal to, say, 6, 7, 8. 6, 7, 8. See, he has not written, but I am writing codomain for your understanding. Codomain of R is equal to 1, 2, 3. All natural numbers will come in codomain. Okay, you understand, na? All natural numbers will come in codomain. Why? Because for y they have not mentioned any this thing, na, control. Define a relation R on the set n of natural numbers by R. Okay? But codomain he has not asked. For your understanding sake, I am telling. Codomain all are there. Why? Because n are there, n are there. But here n only 1, 2, 3 are there. But here they have not mentioned anything. Okay? Relation will be with this formula or condition. Or this is relation. Y is equal to x plus 5 is the relation. Okay? This is not there in question. Just I have written. Domain and range you have to follow. Okay? Then we go for third question. See the third question, what they have written. Set A having 1, 2, 3, 5 as elements and B is having set B 4, 6, 9. Define a relation R from A to B. Here clearly they have given set A, set B. That means you have to make relation 1, 2, 3, 5 and 4, 6, 9 only. Okay, clearly they have mentioned. Okay, now you see, define a relation R from A to B. Okay, what is the relation? Clearly as mentioned in set builder form. For all values of x, y, the difference between x and y is odd. See here, clearly you have to observe. Difference between x and y doesn't mean that x minus y. It may also y minus x. Why? Because he has x belongs to A, y belongs to B. Clearly as mentioned, what is A, what is B. So right here, 1, 2, 3, 5 will come. Here 4, 6, 9 will come. That's all. Okay. Limited. This is A, this is B. You have not asked us to write arrow diagram, but for understanding sake I have written there. Okay. Now let us see. A is there, B is there, but difference between x and y is odd means first you have to take x minus y is equal to, say first I am taking 1 minus 4. Okay, 1 minus 2, 1 minus 3 you should not take. Why? Because he asked us difference between x and y. X belongs to A, y belongs to B, clearly as mentioned. But that means one element you have to take from here and the second element should be taken from here. With the first element you have to see all these three elements difference. 1 minus 4 is equal to R, 4 minus 1, that is equal to 3. Is it odd? Why? Because odd is asking. Yes. That means here I am writing 1 comma 4 is a set. Okay, I am listing out set. Okay, then I am going to take 1 minus 6, that is equal to 5. Why? Because 6 minus 5. 6 minus 1, 5. This is 1 minus 9. No, why can't we write directly? Four minus 1 is equal to 3. 6 minus 1 is equal to 5. 9 minus 1 is equal to 8. These are okay, but this is not okay. 8 is a even number. Okay, 8 is an even number. That is why we should not take it. Now with 1, 3 elements are over. Now with 2 we will see. 2 means 4 is bigger than 2. That is why you have to take 4 minus 2 is equal to 2, even number. 6 minus 2 is equal to 4, even number. 9 minus 2 is equal to 7, odd number. That is why here 2 comma 9 will come. See here you may be subtracting 9 minus 2, but relation should come 2 comma 9 only. Why? Because x is A, B, y is B. Here x is 2, y is 9. Okay, B should be from y. Okay, that you have to understand. Okay, now with 2 also over, 3 times you have to see. 3, 4 minus 3, 1. Yes, okay, odd. That means here 3 comma 4 also will come. Okay, then 6 minus 3. 6 minus 3 also 3. Yes, it is also okay. Then you write 3 comma 6. Okay, then 9 minus 3, 6. No, this is even number. We want odd number. Okay, this relation don't form. Okay, let us see 5. Now 5 minus 4 you have to make. 5 minus 4, that is equal to 1. Yes, okay. That means 5 comma 4 only will come. Why? Because x is A, y is B element. Next, 6 minus 5, 1. Yes, this is also correct. That means 5 comma 6. Last one, 9 minus 5. 9 minus 5, that is equal to 4. No, this is a even number. That means 1, 2, 3, 4, 5, 6. 7 elements are going to come in roster form. This is for your calculation only, but you need not write all these things. you have to write like this: relation R is equal to in roster form 1 comma 4 comma 1 comma 5 comma 2 comma 9 comma 3 comma 4 comma 3 comma 6 comma 5 comma 4 comma 5 comma 6. Okay, this is the answer for your this thing, roster form. Okay, 4 minus 1 3, 5 minus 1 5 minus 1, how it has come? 5 minus 1 shouldn't come, no? 5 minus 1 is 4. Five minus 1 shouldn't come. 5 minus 1 should not do. We have done some mistake. 1 4 1 6. 1 6. 1 6 means 5 will come. That is 1 6, not 1 5. That is 1 6. Here we write 1 6. Some mistake we have done. Okay, 1 6. 9 minus 2 7, 4 minus 3 1, 6 minus 3 3, 4 minus 5 5 minus 4 1, 5 minus 6 1. That's all. 5 minus 9 is 4, don't come. Okay, these are the elements or pairs, ordered pairs, and this is the relation, we can say roster form relation. Now what he is asking again? Write R in roster form, that's all. This is the answer. Okay, you understand now how we have written? But because odd, he only given relation odd, should be odd, difference between these elements. Okay, now we go for fourth question. Okay, see the fourth question. The figure shows a relationship between the sets P and Q. This is P and this is Q. Okay, write this relation in set builder form, roster form. What is the domain and range is asking. Okay, first we write roster form, that is very easy. Then we will see set builder form also. Roster form relation is very easy. R relation R from P to Q. R you can write like this, P to Q. R simply R also you can write. Okay, R 5 comma 3 comma 6 comma 4 comma 7 comma 5. Close. Why? Because see, x coordinate 5 6 7 should come. 5 6 7 x. Y coordinate 3 4 5 come. 3 4 5 in y coordinate. Okay, Cartesians. This is roster form. Second one. Now first one I am writing set builder form. R is equal to, for all values of x comma y. This implies like that meaning. Okay. Now you write. Now observe what is the relation between these two. Y is equal to x is equal to y plus 2 is there. You see 3 plus 2 5, 4 plus 2 6, 5 plus 2 7. You understand na? Then the relation is x is equal to y plus 2. Okay, you write the same. X is equal to y plus 2. Is it correct? X is equal to y plus 2. Why? Because y3, x5, y4, x6, y5, x7. Okay, not it over. But what are the conditions? Why? Because here all natural numbers or something are not there. Okay, then you write y belongs to natural number. Y is greater than or equal to 3, less than or equal to 5. Is it correct? You see, y should see here x is bigger, that is why based on y we are taking x is equal to y plus 2. Okay, y belongs to natural number. Yes, natural number only 3 4 5, but y should be greater than or equal to 3 and less than or equal to 4. 3 4 3 4 5, 3 also will come, equal to is there, 5 also will come, 4 also will come. This is the set builder form of this relation. Okay, now we will write domain and range also. Domain and range. Okay, first let us write domain. Domain is equal to, domain is 5 6 7 only, 5 6 7. Range of R, you write of R. Okay, range of R 3, 4, 5 range. Okay, this is the answer for your fourth question. We will go for fifth question. Okay.